Hello everyone. Here we are going to start our second lecture of the second unit. It means second unit of aggregate topic, that is sieve analysis. So first of all we will see the major classification based on the size and how to classify the aggregate based on the size. So take a sample of aggregate of 2 kg. It means we are taking this as an example. Then sample aggregate is sieved through a sieve of 4.75 mm. The weight retained, it means suppose that the retained weight is 1 kg and weight passing is 1 kg. Then like that shown in picture, that weight retained is known as gravel fraction or coarse aggregate, and weight passed through the 4.75 mm sieve is known as sand fraction or fine aggregate, right? Then this way aggregate sample are divided in two categories, that are core aggregate, the grain size is 4.75 mm, and fine aggregate having grain size less than 4.75 mm. Then we are now study sieve analysis. First of all, what do we mean by sieve analysis? Sieve analysis is gradation test, is a practice or procedure used commonly in civil engineering to assess the particle size distribution. Please do understand this concept. We have to distribute the particles, right? We have to make the classification of the particles on the basis of their size, which are randomly or majorly known as grade test or sieve analysis, also called as gradation of a granular material by following material to pass through the series of sieves, right, progressively smaller mesh size and weighing the amount of material that is stopped by each sieve as a fraction of the whole mass, right? We are going to use the set of sieves, right, and pass the aggregate through that sieves, and we will take the measurement of the weight which of the aggregate sample which remain on sieves, right? Like that we will use for fine aggregate, we will use this set of sieve which is having sizes 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm. Why 4.75 mm? Because it is classifying sieve, right? The aggregates which are smaller than 4.75 mm are known as fine aggregate. So for the sieve analysis of fine aggregate we will use this sieve, right, which is 4.75 mm to 75 micron, right? Then procedure: collect the sample of aggregate of definite weight, suppose that 20 kg. Now for sieve analysis of our sample we will need to set two sets of sieves, one of gravel fraction, it means of coarse aggregate, and another of sand fraction, it means fine aggregate. Now gravel fraction we require sieve sizes from 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm. This set is called as coarse sieves as it sieves coarser particle of soil, right? We have seen that in previous slide. Now second set of sieves for the sand fraction or for fine aggregate is needed, which is of size 2 mm, right, 1 mm, 600 micron, 4.25 micron, 212 micron, 150 micron and 75 micron. If we did mention, then 1 mm is the millimeter is equals to 1000 micron. Please write down this conversion in your notebook, because micron to millimeter conversion, many of the students cannot able to answer this question. How much micron is 1 millimeter, or 1 millimeter is equals to how much micron? So 1 millimeter is 1000 micron, which we denote as a letter micron. So 1 mm equals to 1000 micron. So here 600 microns is actually 0.6 mm. Then for the sieve analysis, we will go towards the sieving of sample. The sieve are stacked one over another with the increasing size of their mesh opening from bottom to top, which means this sieve of large opening is kept at the top. The pan has no opening in place below the bottommost sieve. The soil sample is placed in the top sieve and a lid to cover this arrangement is placed over the topmost sieve. It means we have to pack the sieve sample and the apparatus or sieve set from both sides. At the bottom side we will close it with pan, and at uppermost side or topmost sieve we will cover it with lid. Then the whole arrangement is placed on a mechanical shaker or hand shaker for 10 minutes, and then the arrangement is taken out and the amount of soil or aggregate retained on each sieve or pan is weighted with accuracy of 0.1 gram. Let us say the weight retained on the sieve as follows. See in the table that sieve sizes are mentioned in one row and weight retained is mentioned in another row, right? Such that 80 mm sieve retained no weight of sample, it means 0. 40 mm remains 2 kg, 20 mm 3 kg, 10 mm 7 kg, 4.75 mm 5.5 kg, 2.36 mm 2 kg, 1.18 mm 0.5 kg, 0.6 mm 0 kg, 0.3 mm 0 kg, and 0.15 mm 0 kg, and also pan will with 0 kg weight, right? Then we will, this is nothing but the sieve analysis. Now we come to know that how much quantity of soil aggregate is there of 40 mm, 20 mm or 10 mm, or likewise. Now this is the grading of soil. We graded the soil sample or aggregate sample. Now we have to calculate percentage retained in each sieve. We have to calculate percentage retained in each sieve, such that then we calculate the percentage of amount of aggregate retained on each sieve as a weight of retained aggregate on the sieve divided by total weight of aggregate sample multiplying by 100. It means, please look over here and concentrate on this part. This is main part of this lecture, that we have to calculate the percentage weight retained on each sieve, right? We get the weight retained, then how to calculate the percentage weight retained? Yes, divide the weight retained by total weight of sample and multiply it with 100, you will get the percentage weight retained, right? So we calculate it in next slide. This way we know that the percentage weight of total weight is retained on particular sieve. Percentage weight retained on first sieve is W1 divided by W, it means total weight of sample, and multiply it with by 100, we will get the percentage weight retained, such that percent weight retained on sieve size 80 mm is nothing but the 0 divided by 20, which is nothing but the total weight of sample, and multiply it with 100, we will get the percentage weight retained, which is nothing but 0%. But there is certain weight which remains on 40 mm sieve, which is 2 kg. So percent weight retained on sieve size 40 mm will be 2 divided by 20, it means total weight of sample, and multiplied by 100. So we will get the percent weight retained 10%. Now likewise we will calculate the total weight, percent weight retained on each sieve. So here is the table, and we mentioned all the values which we have calculated. Likewise percent weight retained in each sieve, right? 80 mm sieve, there will be 0% weight retained. 40 mm sieve, there will be 10%. 20 mm, there will be 35%. 10 mm, there will be 35%. 4.75 mm, there will be 27.5%. Now in next column you will see the percent cumulative weight retained. Then how to calculate percent cumulative weight retained? This is again next important part of this numerical. So you have to add whole sum or whole weight of previous sieves to calculate the cumulative weight of that particular sieve. Suppose that if म्हणजे जर का तुम्हाला 40 mm सिवचा कम्युलेटिव्ह पर्सेंट वेट रिटेन काढायचा असेल तर पर्सेंट वेट रिटेन ऑन 40 mm सिव किती आहे 10% प्लस त्याच्या अगोदरच्या सिवमध्ये किती पर्सेंट वेट रिटेन झालेला आहे 0 mm म्हणजे 10 अधिक 0% कम्युलेटिव्ह वेट रिटेन किती येणार तुम्हाला तिथं 10. तसंच जर तुम्हाला 20 mm सिववर किती पर्सेंट कम्युलेटिव्ह वेट रिटेन झालं हे काढायचं असेल तर तुम्हाला सर्वात अगोदर 20 mm सिववरती किती रिटेन झालेलं आहे ते बघायचं आहे. ते 15% आहे आणि त्याच्यावरच्या जेवढ्या सिव्ज असतील तेवढ्या सिव्जच्या पर्सेंट वेट रिटेनची ॲडिशन करायची म्हणजे 15 जे की 20 mm सिववरती रिटेन झालेलं आहे आणि त्याच्यावरती 40 mm सिववरती किती रिटेन झालेलं आहे 10% आणि 80 mm सिववरती किती रिटर्न झालेलं आहे 0%. म्हणजे 0 अधिक 10 अधिक 15 ज्याची बेरीज येते 25. तसंच तुम्हाला खाली कॅल्क्युलेशन्स करत जायचे राईट. यू हॅव टू कॅल्क्युलेट लाईकवाईज अप टू द सॅम्पल पॅन गिवन or sizes of pan given. We had given with the size of pan 0.15. So you have to go with calculations up to 0.15 mm, right? It means 0.6 mm will have cumulative weight of 100 mm, but it doesn't have percent weight retain, but it will have cumulative weight retain 100. 0.3 will also have 100 and 0.15 will also have 100. So and now we have to sum this total cumulative weight. शेवटच्या कॉलम मधले जे काही cumulative weight आलेले आहेत त्यांची तुम्हाला बेरीज करायची. मग त्याला म्हणायचं टोटल cumulative weight retained. It will be 680, राईट. ते किती येईल 680. मग आता पुन्हा दुसरा याच्यात कन्सेप्ट आहे तो फाइननेस मॉड्युलस. व्हॉट इज फाइननेस मॉड्युलस, राईट? The definition of fineness modulus is the sum of cumulative percent retained, right, is divided by an arbitrary number 100 and the result value is known as fineness modulus. So write down this definition in your notebook also. So fineness modulus is the summation of, it means addition of cumulative percent weight retained divided by 100. The main objective of finding fineness modulus is to grade the given aggregate for the most economical mix for the required strength and workability with minimum quantity of cement. So this is main aim of the sieve analysis or grading test or finding the fineness modulus. So fineness modulus for fine sand will be 2.2 to 2.6. For medium sand it will be 2.6 to 2.9 and for coarser sand it will be 2.9 to 3.2. Now we will calculate the fineness modulus for previous problem which we had seen, right? Fineness modulus for previous problem will be summation of total cumulative percent weight retained divided by 100. Now what is total percent weight cumulative retained is 680 and total percent cumulative weight retained divided by 100, it will be 6.8. Now the given sample is coarse aggregate having fineness modulus 6.8, right? Now everyone should able to calculate the fineness modulus, right? So this is practice problem for you. Sieve analysis of 500 gram of sample is conducted and following observations are noted. Find the fineness modulus of sand. In first row it is given with sizes of sieve, and in second row it is given with weight retained on that sieve, right? If anybody is having any problem in this lecture, please do ask in comment section. I will once again repeat you for you the previous slide, right? We have to calculate the fineness modulus of previous problem. So what is the formula for fineness modulus? What is the formula for fineness modulus? Total percent cumulative weight divided by summation of percentage cumulative weight divided by 100. So we will consider here, or we have calculated here, the cumulative percentage weight retained on sieve is 680 divided by 100. We will get 680 divided by 100. We will get fineness modulus for that sample will be 6.8, right? So please totally go through the lecture, and if anyone having any problem in this lecture, please do ask in comment section. Thank you.